So in the last video, we talked about transforming data using addition and subtraction. And now we're going to talk about transforming using multiplication and division. We're also going to put the two together with an example by the end of this video. So one thing that I need to mention is when we were transforming data with addition and subtraction, we were affecting measures of center and location, right? So the location of variables change, the location of the IQR change, and then the measures of center, their location also change. We're talking about mean, median, and so on. But what was not changed was the spread and the variability of the distribution, right? So if we look back, right, real quick, right? If you look back at these two data sets that we transformed by addition, right, we just added 5 to the original data set, you'll actually notice that the range of the data set is exactly the same, right? So the range in data set 1 is 30, right? So maximum minus minimum. And the range in data set 2, the adjusted data set by addition, is also 30, right? And you can see the interquartile range also doesn't change. The interquartile range in the first data set is 16.5, and the interquartile range in the second data set that was adjusted using addition is also 16.5. So addition and subtraction do not have an impact on measures of spread, okay? And so, of course, the reason why I'm setting this up is because when we start talking about multiplication and division, these are going to affect measures of spread, okay? So range, interquartile range, standard deviation, they will be affected by transformations using multiplication and division. Now, the one thing that remains constant regardless of addition, subtraction, multiplication, division is the shape of the distribution, the general shape, right? So if you have a skewed distribution, it doesn't matter how many transformations you apply by addition, subtraction, multiplication, division. However you transform it, you're not gonna make a skewed distribution symmetric by transforming it in this manner, right? And you're not going to make a symmetric distribution all of a sudden skewed by applying any of these transformations, right? The shape is uniform regardless of what transformations you apply here. But okay, so in the last video we called the constant of addition and subtraction A, so we'll call the constant of multiplication or division B, okay? So here's kind of like your brief definition to get us started. So multiplying or dividing by the same, okay, and this is for all observations, of course, so multiplying, dividing by the same positive number. We'll talk about why positive number in a second. Okay, and it should make sense why we're going to be multiplying by a positive number, right? So if you have most distributions, right, deal with like the natural positive numbers. I mean, well, not necessarily natural numbers because you don't necessarily need to use counting numbers, but you're going to be dealing mainly with positive numbers, right? So it's very, very rare that we're going to be multiplying or dividing distributions by a negative b. Now, we can do that if we'd like, but we're going to see that some of the transformations that b has, we're going to have to use the absolute value of b anyway, right? So that's kind of something we'll talk about when we get to linear transformations of data sets. But for now, we'll keep it simple and just restrict b to be a positive number. So multiplying or dividing by the same positive number b, we'll have the following impacts. So impact number 1, and we're always going to talk about these impacts in terms of the 4 characteristics we talked about, which are shape, center, spread, and outliers, okay? So it'll multiply / divide measures of center and location by b, okay? And again, I'll put it in single quotes here, just so it's clear that this is a variable we're talking about here, or a constant, I suppose. So multiply / divide measures of center location by b. So you take the mean, median, you take any observation, you multiply and divide them by b. Okay, that makes sense. That seems reasonable. However, as well as affecting the center and location of the distribution, it will also affect measures of spread, okay? So it will also multiply and divide measures of spread. Okay, and of course when I say spread, that also assumes like variability as well, right? So measures of spread by B. And what are the measures of spread we're concerned with? We're concerned with range a little bit, IQR, and of course our boy standard deviation. Okay, so let me pull this up a little bit. So standard deviation is going to be the big one here, right? Because standard deviation is one of the main measures of spread that we're going to be concerned with as we go through any statistics course, right? So multiplying a data set by some factor, dividing a data set by some factor is going to change your standard deviation by that factor, okay? And as we said, right, just to be extra clear about this, this will not change the shape of the distribution. Okay. Now, I want to do one example where we talk about strictly just multiplication or division. Okay. And after that, I want to do in a separate video, I'm going to go ahead and combine both transformations using multiplication, division, and addition or subtraction. Okay, so we're gonna kind of delve into how we can use both transformations at the same time. Now I'll get a separate sheet of paper. Probably should start the page. And here's the hypothetical I'm going to give you. It's a pretty basic hypothetical that we use in this chapter. So let's say you sell t-shirts online. Okay. You have your own company that sells t-shirts online, okay? So here's the distribution of sales over the last 10 days, okay? And by sales, I mean, so I should say distribution of number of sales, okay? So I'm going to give you a distribution of the number of sales you made, and I think you can already kind of see where this is going, how I'm going to apply multiplication here. Okay. So over the last 10 days, let's pick some I guess convenient numbers. So day 1 you sold 5, day 2 8, 9, 10, 12. How many data points do I have? 8. We'll just add a couple more. 13 and 15. Okay, so here are your sales. You're small online company. You're building yourself up, right? But still respectable. Of course, this data is going to have a mean and a standard deviation, right? So we can go ahead and calculate that. I'll use my. I'm going to be using my TI Nspire on my computer. So let me go ahead and calculate these out for you guys. Should have had this prepared probably, but it's okay. So we'll do our one variable statistics calculations on this data set. That way we can go ahead and kind of see how these statistics transform as we apply this multiplication, which we're going to introduce in a second. Okay, so this has a sample mean x bar of 10.1, so on average you sold 10.1 shirts over the last 10 days. Okay, we'll have a couple of one variable descriptive statistics here to kind of see how all of them transform, right? So I'll use Q1 and Q2 as well. So Q1 is 8, median is 9.5, and I think you guys can probably determine that just by looking at the data set, right? Q3 is 12. Okay, our standard deviation, so well, first of all, our IQR, I'll put these all together since they're all related. IQR is 4, and then our standard deviation, okay, we'll call it S for sample standard deviation. S sub x is 2 point, I'll go 4 digits, why not? Okay, so you can verify these in your calculator, and there you go. So we have our descriptive statistics for this distribution, and now we're going to see what happens. Well, although we're interested in the number of t-shirts we sell, what we're really interested in is our profits, right? So let's say you make, let's give you a nice profit margin. You make $7 on every shirt sold. Okay, so what we're going to do is we're going to create a distribution. Okay, so describe, specifically, we're going to describe the distribution of profit over the last 10 days. Okay, well, how are we going to describe that distribution? Well, if we look at our shirt sales, for each shirt we sell, how much profit are we making? We're making $7 on each shirt sold. So if I sold $5 or 5 shirts in the first day, how much profit did I make in day 1? Well, I made $35. If I sold 8 shirts, then multiply that by 7, and so you get $56. 56, right? Multiply it by 9, you get 63, 63, 70, okay, 84, 84, 91, okay, and then we go to 105, all right? So here, you can see, how did I transform the data? Well, I just took each number of shirt sales that I had on a given day and multiplied it by my total profit, which is $7, okay? And again, we'll put this through I'll put this through my calculator right now. You guys can also do the same, of course. And we're going to see, well, we should know what's going to happen just by the definitions that I laid out earlier, right? So what we should expect to see is we should expect to see basically all of these values be multiplied by 7, essentially. Okay? We should expect to see all these values be multiplied by 7. So let's go ahead and make sure that that's the case. All right, 84, 84, 91, and 105. Okay, well, lo and behold, right? So my new, again, we'll call this x bar 1, we'll call this one x bar 2. Okay, my new mean is $70.7, right? Okay, so we have $70.7 on average over the last 10 days. Okay, that's our average profit over the last 10 days. Okay, I'll keep the descriptive statistics from the first data set up there so you guys can compare and contrast, right? I'll actually go straight to standard deviation, okay? So that the standard deviation of x2, right? I'll give this a little subscript as well, just to be thorough. Okay, the standard deviation comes out to 20.4616, which if you check, this is exactly 7 times more than what we had here, of course accounting for rounding errors and whatnot. Okay, quartile 1 is all of a sudden, and this is pretty evident, right, is now 56. Quartile 3 is now going to be 84. Okay, our median is now 66.5, and our IQR, as you guys should be able to see, is 28. And you can see all of these changes from these 6 descriptive statistics to these 6 over here. Well, this is just, and let me include units, right? These are just 7 times more than any measure of center or spread from the previous distribution, okay? So this is true for any distribution, okay? And this is nice because obviously as we move on, we're not going to be dealing with sample sizes that are this small and convenient such that we can transform every single individual variable. What we're going to have to do is we're just going to have to transform the descriptive statistics essentially. Okay, so that'll wrap it up for this video. I'm going to make one more for combining both addition and multiplication into a transformation.